Okay, here in section 5.4, we're going to talk about how to solve trig equations, which is going to become very important in your study of calculus. And so one thing that we're definitely going to need in this section are trig identities. And we already know several different basic trig identities, such as quotient identities, reciprocal identities, and Pythagorean identities. We're going to add on to that in this section as well. And then we're also going to need to know those unit circle values so that we can find the correct solutions given the equation. And so go back and refresh yourself on those if you need to. I'm going to assume knowledge of those unit circle values as we're solving equations. Okay, the final set of identities that we're going to learn here in pre-calculus are called the double angle identities. And they are so-called the double angle identities because they deal with if I have sine of 2x, let's just say, and sine of 2x is going to equal to 2 times sine of 1x times cosine of 1x. Now, there is also a double angle identity for cosine of 2x, and cosine of 2x is going to equal to cosine squared x minus sine squared of x. And this is an identity that we looked at in the section 5.1 through 5.2 notes. And so there are two equivalent expressions to this, one of them being 2 cosine squared x minus 1, and the other being 1 minus 2 sine squared of x. And which of those three that you pick is going to depend on what's in the rest of the equation. So for example, if the rest of the equation has cosine, you're going to choose the second one here that's only in terms of cosine. If the equation only has sine, you're going to choose the third option, which is only in terms of sine. And so which one you use is going to depend on what the rest of the equation looks like. Okay, so here in example 1, we want to solve the equation on the interval from 0 to 2 pi. And so we're going to have to use our factoring skills in a lot of these problems in order to solve it. And so what I notice here is that I have tangent squared x plus tangent x is equal to 0. And so both of these terms have a tangent x in them. And so what I'm going to do is factor out the greatest common factor there, which would be tangent of x. And so that's going to give me tangent of x plus 1 left over on the inside of the parentheses. Now that I have two factors and they're equal to 0, I'm going to set each one of them individually equal to 0, and then I'm going to try to solve. And so I end up with tangent of x is equal to 0. And so I need to think, when does tangent of x equal to 0? Well, that's not a unit circle value on my chart. Remember, my values on my chart for tangent are square root of 3 over 3, 1, and square root of 3. 0 is not one of those. And so tangent x equals to 0 might happen on a quadrantal angle. And so let's think about my quadrantal angles. If we want tangent x to equal to 0, I know that by definition, tangent x is y divided by x equals to 0, and that fraction y divided by x is going to equal to 0 whenever the numerator, or more specifically, when y is equal to 0. And so where on the unit circle is the y-coordinate 0? Well, that would be here at 0 radians and here at pi radians. And so the solution to this part of the equation will be 0 and pi. Now, technically, it would also be 2 pi, but notice that we're only answering on the interval from including 0 until 2 pi not included, and that's why I don't write 2 pi as an answer. Now, for the second part of this equation, we get tangent of x is equal to -1. Now, -1 is a value on my chart. It happens right here, and the angle that would be right there is pi over 4. But I need to figure out what quadrants these angles are going to come from. So where is tangent of x negative? Well, if I use my acronym, All Students Trust Castle, I know that tangent is negative in quadrant 2 and in quadrant 4. And I want the reference angle in those quadrants to be pi divided by 4. And so I'm going to put pi divided by 4 as the reference angle in quadrant 2 and in quadrant 4. And so in quadrant 2, pi minus pi over 4 is going to get us that angle, because we're going to be here at pi and then go backwards pi over 4. And so pi minus pi over 4 is going to be 4 pi over 4 minus 1 pi over 4, which will give me 3 pi over 4. And so that will be one of my solutions. The other one in quadrant 4 is going to go from 2 pi backwards a pi over 4, and so 2 pi would be like 8 over 4 minus 1 over 4, which would give me 7 pi divided by 4. And so I have 4 solutions to this equation: 0 pi, 3 pi over 4, and 7 pi over 4. Okay, here on example B, we notice that there are 3 terms, and this is in a quadratic form. And so I'm going to factor this as if it were a quadratic. For example, 2x squared minus 5x plus 2 is equal to 0. But instead of x, obviously x has been replaced by sine of x. And so if I were going to factor this quadratic, I would need to multiply the ends, since this is a lead coefficient that's not equal to 1. And so the multiply number would be 2 times 2, which is 4. And the add number would be -5. And so the two numbers that multiply to 4 and add to -5 would be -4 and -1. And so I'm going to come over here, I'm going to write down the ends of this expression, and in the middle I'm going to have 2 terms that have sine x, one of them with a coefficient of -4 and the other with a coefficient of -1. And then when I group together the first 2 terms, I'm going to factor out a GCF. And so what do they have in common? They have a 2 and a sine x. And when I factor out a 2 sine x, I'm going to be left with sine x minus 2. From the next 2 terms, I can take out a -1, and so that's what I'm going to take out. And that's going to also leave me with sine x minus 2 is equal to 0. And therefore, my 2 factors are 2 sine x minus 1 and sine x minus 2 is equal to 0. Now, I'm going to set both of these factors equal to 0, and so when I set the first factor equal to 0 and solve for sine of x, I'm going to get sine of x is equal to +1/2, and for the second one, I'm going to get sine of x is equal to 2. And so I'm going to focus first on sine of x is equal to 1/2. And I remember that in my table of values, 1/2 is one of my unit circle values that corresponds to the angle pi over 6. And so that's the reference angle that I need to focus on here for the first part of this equation. And so pi over 6 is the reference angle, but I've got to also figure out what quadrants sine of x is positive, and more specifically +1/2. But let's start with positive first. If I put together a coordinate plane here, then using my acronym, All Students Trust Castle, I see that sine is positive in quadrant 1 and in quadrant 2. And so I want the reference angle in quadrant 1 and in quadrant 2 to be pi over 6. Well, in quadrant 1, that's obviously very easy. That's just going to be pi over 6. And in quadrant 2, we're going to have to subtract that reference angle, pi over 6, from pi. And so pi subtract pi over 6 is going to be 6 pi over 6 minus 1 pi over 6, which will give us 5 pi over 6. Now, for sine of x equals to 2, that is actually not possible, because remember, the range for sine is between -1 and 1, and 2 is not between -1 and 1, and so I'm not going to get any answers from this factor, sine of x equals to 2. And so the only 2 solutions on the interval from 0 to 2 pi for this equation will be pi over 6 and 5 pi over 6. Okay, here on letter C, I see for the first time that I'm going to involve a double angle identity, because I have here sine 2x, and I need to fix that in order to be able to solve the equation. And so the only option for sine of 2x is the identity that's equal to 2 sine x times cosine x. And I'm going to go ahead and make this equal to 0 by subtracting over 2 cosine x. And so that's going to be minus 2 cosine x is equal to 0. And now I want to pull out a greatest common factor. And so I see that from these two terms, both of them have a 2 and both of them have a cosine x. And that's going to leave me with sine x minus 1 is equal to 0. And so now I have two factors. I have 2 cosine x, and I'm going to set that equal to 0. And sine x minus 1 equals to 0, which is going to give me sine x is equal to 1. On this first equation, you can just divide by 2 on both sides, and so you get cosine x is equal to 0. And remember, that happens on a quadrantal angle. Cosine x is the x-coordinate on the unit circle. So if we think about where is the x-coordinate 0, that would be here at the point 0, 1, and here at the point 0, negative 1. And so what are those two angles? Pi over 2 and 3 pi over 2. That is where my x value is going to be 0, and remember that cosine is the x value, and so this is going to be x is equal to pi over 2 and 3 pi over 2. Now, sine of x equaling to 1 means where is the y-coordinate equal to 1, and that is again going to happen at a quadrantal angle, and the only quadrantal angle where the y-coordinate is positive 1 is again at pi over 2. And so I'm not going to repeat that answer. I'm just going to write down below this, just really more for you than anybody else, right? X is equal to pi over 2, and then since I already have that listed as a solution, I'll just go ahead and box these two answers down here. And so pi over 2 and 3 pi over 2, again, make sure if you have a double angle in the equation that you use one of the double angle identities to get it out of the equation and back in terms of a single angle.